Lakehouses, warehouses, SQL databases, SQL endpoints, a lot of ways to run SQL code in Microsoft Fabric. Let's clear up the dust a little bit. Today we are talking about Fabric warehouses. As always, we will first go through the architecture and from time to time look into how it really works in Microsoft Fabric. So when we start, we have different options to run SQL code in Microsoft Fabric. So when we have a look at the Fabric periodic table, we see that we have the Lakehouse with a SQL endpoint. We have the warehouse with a SQL endpoint. We have the SQL Analytics endpoint itself separately pointed out. And we have the SQL database in the periodic table as a different option. So today it's about the warehouse. So let's go to the warehouse. We have different scenarios here, but of course we will go a little bit deeper today in all the details. So let's have a look at the different options. So SQL options in Microsoft Fabric. So first there is a SQL endpoint in the Lakehouse. So what's the limitation of the SQL endpoint, or what's the purpose of the SQL endpoint in the Lakehouse? The main point here, it is read-only. So you cannot write. This is by design, because the idea is that you write with Spark directly to the Delta files, and you would run into concurrency issues if you would be able to write in parallel in the SQL endpoint. When we have a look at the warehouse, we have also a SQL-like endpoint, but in reality it's a SQL engine, so it's something completely different. It's the SQL engine, and the SQL engine is read-write. So this is like the big feature, but you have much more speed, you have more capabilities, and you have more configuration options. And as a third option, you have the SQL database in Fabric. The main point for the SQL database, which we cover in a separate video, is that the SQL database is automatically mirrored in the OneLake, but it's more designed for application usage. So when you have an application that needs a SQL database, you can write in the separated SQL database while still having everything in OneLake. So this is like a hybrid benefit, so to say. So these are the different SQL options, just to go through it and mention that a little bit. The good point is, when you love SQL, then Fabric is the way to go for you, because you have plenty of options. You have same storage, different engines, so everything ends up in OneLake. So OneLake is like on top, right? OneLake uses Delta tables. So let's draw them in here. Delta tables. So everything is OneLake, which is really great. I really like OneLake. When we have a look at the SQL engine in the warehouse path, SQL in the warehouse path, then we have the read and the write capability. So this is read, write. So everything possible with warehouse SQL engine. When we have a look at the Lakehouse path, So the Lakehouse path is a little bit different because we have in the Lakehouse path the Spark engine. And the Spark engine supports read and write. But the SQL endpoint supports only read. So that's the main difference. Same storage, different paths, different engines. Which means that you have different SQL capabilities compared between Lakehouse and Warehouse. So on the SQL endpoint, which means Warehouse, you have select. Yes, but you don't obviously have anything of create, insert, update, delete, something like that. Not working. Everything not working, right? So the only thing that really works is select. Everything else forbidden, and you don't have stored procedures. Also. In the Warehouse path, Warehouse, of course you also have select, but you have also create, insert, update, delete, and so on works. And of course you also have stored procedures. Right? So this is like highlighting all the differences in between Lakehouse and Warehouse. Okay, so let's start with creating a warehouse. Very straightforward. New item, warehouse. Let's give it a name. There we go. It's now creating our warehouse. And we will then import demonstration data into that warehouse. So now it's, yeah, I see it here. You can add sample data. That's pretty. And we are back. We have some sample data included, but of course this is not a real world case. So let's switch to a more real life case, and let's incorporate a proper importing. So let's first create a new warehouse called Wide World Importers. And then we can start with ingesting data into that warehouse. So we will use several methods to ingest data, and we will start with a very simple one, which is a copy job. So when we go in our warehouse, we have a very simple get data here. And in the get data section, we can select a new pipeline or a new workflow. And we have a new way of going directly to the workspace and selecting directly a copy job. So this is like load customer data. There we go. And this creates for us a new copy job directly in the workspace. And as you can see, it basically creates a pipeline with a copy job driven by a wizard. So let's go through that wizard. And when we go to the sample data import, you see that we have the retail data model from the Wild World importers. Very, very simple. So, there are previews, but We will see the data later, so I think that's okay. We can select an item, our wide world importers warehouse as a target. We have the full copy option because, well, this is a demo workspace, obviously, right? So pretty straightforward. And we see the source and the target and the table mapping, right? For all this data stuff. So that's fine. Dimension city and so on, right? This is our target. Full copy. We see that this is the destination here, the source and the destination, and we can edit the color mapping, right? To make it easy to do some adjustments during the import. So for this case, we will leave everything as default. Just hit next and save and run. And you see we have our pipeline configured with source and destination, and the copy job is here. There we go. So our run succeeded, which is great. Let's have a look in our warehouse. There we go. We have the different dimensions and the fact sales table and so on. So that looks very good. So now everything is properly imported. Well, honestly, I forgot the schema. So I re-imported everything, but the job is still the same, the copy job. And so I just typed in the DBO part. So now we can continue with filling our warehouse. Let's do some fancy stuff. So for example, we can write a simple SQL query here, and let's run that query. So we select the top 10 from customer key and customer and the sum of total including tax. So just a simple, so to say, sales report. The second thing that we can do is we can clone some tables, which is very, very easy in Warehouse. So we can create a clone from dimension city and from fact sale. So we clone the schema and the data then. And you will see in a second that we have a dimension city now twice. It's dimension city and dimension city 1. So we can clone data from the current status. We can clone data from previous states, which can also be helpful. But let's move on and let's transform data with a stored procedure. Stored procedure is like a program written in SQL. And I've prepared one, so we drop the existing stored procedure if there exists one, and then we create a new stored procedure that creates new tables. So we drop that tables when they exist before, create a new table, and then load data from the existing tables with some functions into the newly created table. So let's run this stored procedure. And the result will be that we have a new aggregate sale by date city table after the execution went fine. First, we will get the stored procedure. You see it here. This is the one that we have created now. And when we then run the stored procedure, which is the next step, obviously, then our table will be created. So let's run the stored procedure as like a program. So we execute that program now. Let's run it. And we will see then the newly created table in after the completion. So it's running 10 seconds now in our table section. So it succeeded. Let's refresh. Oops, excuse me. There we go. Aggregate sale by date city. There we go. This is the aggregated table out from our stored procedure. what's like the decision matrix? When to go with Lakehouse, when to go with Warehouse? Let's go through it. So the first question is, do you need to write? Need to write with SQL. So the point here is SQL, right? Because, of course, with Spark, you can also write. It was a little bit too long. So, need to write with SQL. If yes, if you need write access with SQL, then the question is, do you need it transactional or do you need analytics? So when you need analytics or you need a data warehouse, then of course go with, no surprise, Warehouse. When you don't need analytics, but instead of that you need just transactional, OLTP, then go with SQL database in Fabric. SQL database in Fabric. When you don't need write access with SQL, you can go with Lakehouse plus the SQL endpoint. When you need Spark ML, oh, that was too fast, excuse me. Next question is, do you need Spark ML? Spark ML, that's not nice today. Well, anyway, do you need Spark ML? If yes, you can go with Lakehouse. If you don't need Spark at all, you should still, and that's the main point here, you should still consider Warehouse, because there you have the more complete SQL capabilities, right? You have better SQL capabilities. Since you have such a bunch of options how to access your data, let's say you have two like access points. One is a notebook and one is Power BI. And you have your workspace with different items. That's your workspace. So with Notebook, you can easily access your Lakehouse with Spark, obviously. And from there, you could easily access your warehouse with shortcutting, for example. Which means that you can cross-access your warehouse through the Lakehouse for the notebook. This is a path. You can also directly from a notebook read the warehouse, of course, no problem. From Power BI, you can also directly access your Lakehouse. You can directly access your warehouse, no problem. So the main benefit is here that you can plump together warehouse and Lakehouse with the shortcut way. Let's explore the different options to get data into the warehouse. So let's say we have an ADLS v2 Azure Data Lake Storage. Then the fastest way is to use copy into. Let's say fastest. Let's say we have another lake house. It's about moving data, right? It's not about shortcutting and so on. Let's say Lakehouse. Then we have the good old CTAS option, create table as select. This gives us the benefit of transform and load. Let's say we have any other warehouse. What always works, let's say other warehouse. What always works is the good old insert plus select. But as you know, this has some potential issues because it could be triggered and you have many small insert statements, and let's talk about database logs and so on. When you have multiple sources, then you have the good old pipelines. The copy data activity also, by the way, and we have data flows. And we would have Apache Airflow. So, but these are the most obvious options then. In any way, whatever way you choose, your data will end up in the warehouse. So these are like the different ways to move data in the warehouse. There we go. About the warehouse internal architecture. When you issue a query to the warehouse, the query processing starts. Query processing, the first step, of course, is your T-SQL query. This T-SQL query then goes to the Unified Query Optimizer. When you know about SQL Server, you know that all queries are optimized, so same here. All of that, there is a plan built, same as for SQL Server. This is a distributed execution plan. Exact plan. The plan how the query will be executed. And then the query is submitted to the nodes, and the nodes are auto-scaled if needed. So this then goes to nodes, auto-scaled. Not your business. So this is basically the query processing part. So let's draw a box here around that. And the next way is to the storage layer. Let's go there, storage layer. The storage layer has an in-memory cache for performance. And from there, it goes to the OneLake Delta Parquet files. Not MDF LDF. This would be a SQL database. So it's Delta Parquet, but you cannot access the files. That's the difference, the main difference to Lakehouse regarding file system. You have several background processes running. One is auto-compactation. Auto-compact. You have auto-checkpointing for log management, and you have auto-garbage collection. Garbage collection. So these are the three auto processes that are running in the background. This happens when you issue a query to the Lakehouse. Then first you have the query processing, next you have the storage layer, in the background you have the background processes. So let's do some time travel in our warehouse. First we will create a view for the top 10 customers, and we will use that view in the subsequent queries for our time travel. So this is the view we have just created. We see the top 10 customers, obviously. So the next thing that we will do is we will change our underlying data. So let's create a new SQL query here. And you see we will go to the fact sales table, and that's the total including tax. For the sales key, this is tailspin toys. So we have tailspin toys here, right? Here's the total sales amount. So this thing will change, obviously, quite a lot, right? We will get back the current timestamp, so we can time travel with the timestamp that is returned. So let's do that. Query is running, and this is the timestamp, and I will copy that timestamp for later reference. So let's see the result. So what I basically did, I wrote a very short query, selects everything from top 10 customers with the given timestamp, which is the updated one. So you can see that the tailspin toys has an 8 at the beginning. That's everything we need to know. So let's get back just 1 minute and let's run it again. And you see that the tailspin toys now has a 6 at the beginning. This is a 2 that we changed, right? So this is time travel that you can do with options on the query. Next, let's create a visual query. We have a drop down here, and we can say new visual query. And next we can start to drag our tables in there. So of course we will need the fact sales table. So let's drag and drop the fact sales table in here. And we can apply options on that. So for example, we can keep the top rows, and let's keep the top 10,000 rows. There you go, from the table. And next we can add the dimension city table. There we go. And now we can combine and merge these two queries as a new table. So we have dimension city, and we will use the city key, and we have the second table, fact sales. So this is like the matching column, city key to city key, and the join is inner join, so we will get only the rows from both tables that match. So we have now our merge table. At the last column we will see, there we go, you will see the fact sales table, which we should expand. We just need 3 different columns. We need the text amount, we need the profit, and we need the total including tax. These 3 columns. When we hit OK, these 3 columns are expanded now, and the remaining columns are discarded. Next, we can group this query, group by. And first we will group by country. Second, we will group by state, province. And third, we will group by city. That's great. And in the new column name is a sum. So let's go to sum, and the name is then sum of tax amount for these groupings. We can add a next aggregation. The next aggregation is sum of profit. This is the sum obviously on the profit column, and we can add sum of total including tax. This is again a sum, and this refers to total including tax obviously. Once we hit OK, the grouping is applied. Yeah, there we go. So we can rename our query. This is a sales summary. Let's rename that query. So this is the visual query builder, and I think it's a big advantage, especially for an explorational approach on data querying. Beside of the SQL query option, the visual query option, we have a new SQL query in notebook option. So let's go with that. This will create a new notebook for us. And we have on the left side all the items from our warehouse. So we, for example, then can click on the ellipsis of the dimension city and say, hey, please select the top 100. And this will insert the SQL code that we can run directly in that notebook, which is also very handy. And the result is displayed inline, which I think is a great way, especially for data exploration. We can also use Lakehouses, which use Spark to query our data. So let's try that when we create a new Lakehouse. Very simple. Let's say that's a shortcut exercise. This way. So that's pretty straight. Then we get directly from the introductory page the option to create a new shortcut. We will go with OneLake and to the wild world importers. And there we can select a table, for example, the dimension customer. There we go. Yeah, so let's include that. What's next? And it's loading. So I think the previous result was somehow wrong, so I just deleted the result because it was a bit funny on the JSON stuff in there. So this is how it should look like. So we can select dimension customer and let's hit create. This now ends up in the shortcuts exercise schema DBO table dimension customer. And from there on, we can create a new notebook to analyze that data. This notebook then is linked to our shortcut exercise Lakehouse, and we can simply drag and drop that, and it will create a data frame because not SQL, it's Spark now. Oh, and I have to resize my capacity. That's my fault, but in general, we could query with Spark QL directly the data. Give me a second, I will be back right. So capacity is resized, and now we will most probably see the result of our Spark QL query. There we go. So this is how we can use shortcuts to continue our work within Lakehouses. What we can do now is we can do cross queries. So cross warehouse queries. So let's create a new query. this is a wrong clipboard content. So I have pre-created a query, and it uses our warehouse tables, obviously, but you see the reference here, inner join to the dimension customer of our shortcut exercise Lakehouse. So let's run that. And the result will be a combination from warehouse content and Lakehouse content. And the result of our cross warehouse Lakehouse query has arrived. Okay, next let's have a look at row level security. So I've created a new schema called sales. I have created a very simple table with sales ID, sales rep, product name, sales amount, and sale date. And I've put my name in some columns as a sales rep and sales2@contoso.com in other columns. I've already created the table. And next, let's create the row level security. So if we create a new schema, and then we create a function, which basically returns the table with schema binding. And when the sales rep equals the username, or the sales rep equals manager@corporatesoftware.ch, then it will return either only the sales rep data or all data. That's the story. So query execution time was there. So let's have a look at our table. And you see, I see only line 1, 3, and 5 because row level security is active. I have, you see, it's state on. We can move it to state off, and then I would see all rows again because row level security would not be active again. So how does transactions work in warehouses? So first you have the user, and the user starts something with begin transaction. In the background, this issues a snapshot then to ensure a consistent state. So we have the warehouse that gets the begin transaction. From there on, the data update is issued. Update, let's say customers said something. We don't need to write that down. On the customers table then, this is issued, and there is the value update done with insert into. That affects, let's say, another table, orders. So we have two tables affected, customers and orders. And then the user issues the commit. Then the question is everything committed? Yes, this one is committed. Yes, this one is committed. If any operation failed, there is no commit issues. And when something fails, then there is a rollback issued, which is a rollback on the first layer and a rollback on the second layer. So this is basically how it works. Works on performance. Obviously, when you load data for the first time, so when you issue your query, and you don't have a cache hit, so cache is cold, then the query needs to load the data from OneLake, and beside of returning you the data, it's also putting the data in the cache, obviously. So the first result will be slower, and the second result from when the cache is green will be faster, obviously. The interesting point is that you can check with data scanned remote storage and the query insights, or whether and how often the cache is hidden or not. So you can optimize and analyze your query results with the built-in query patterns in the data warehouse. Link that to the medallion structure. For the medallion structure itself, we will do a different video, but for now, let's say we have bronze, silver, and gold. And usually you go with Lakehouse for bronze, you go with Lakehouse for the cleans data and silver, and you will go with Warehouse in gold. That's a pattern. From bronze to silver, you can go either with notebooks, you can work with shortcuts, you can work with data flows, whatever you need. And from Lakehouse to Warehouse, you usually will go with CTAS, create table as select, or with insert. And of course, you can use also a pipeline. And from gold, the reporting layer then is going to Power BI and other targets, of course. When you use Synapse, dedicated SQL pool, and you want a dedicated SQL pool, and you want to migrate, you have basically 3 different artifacts to migrate. The first one is the schema or DDL. The second one is data, and the third one are stored procedures. So for the schema and DDL part, you could go with Data Factory. You can migrate DDL plus data, or you could go with the DBT adapter. You can then also migrate DDL plus data. Second option. For the data itself, you could go with CTAS to ADLS to extract the data. And for the stored procedures, you basically need to do a manual review. Or you could go with large language models if you want. In the warehouse, the target you have again schema plus DDL, and obviously the target for schema and DDL is this one. You have the data, and you can have 3 ways to migrate the data. And the stored procedures are coming when you migrate them individually, are from manual review. So that's a pretty obvious walkthrough for schema, DDL, and data, and most people will migrate the DDL and this schema, DDL and data together. The community questions. So first and foremost question is, why does Fabric has both Warehouse and Lakehouse when they do use the same storage? So, well, I understand the use case, Warehouse versus Lakehouse, where the team is more familiar with T-SQL and the other ones are more working with structured data. So great question. So Warehouse advantages over Lakehouse. First one is multi-table ACID transactions. You have transaction capability. Second is zero copy table clones. We have seen that. So it's very simple to make a snapshot from a table. You have time travel queries with a built-in point in time, and you have auto optimization, and you have much better performance. Next question is, will Parquet files that are no longer needed be removed? Are they billable? Do I pay for storage that I don't need anymore? So garbage collection is inside of Warehouse. So in most scenarios, except for expired log files, the Parquet files that are no longer needed are grabbed very, very soon. Can I read Warehouse Delta files directly with Spark without the Synapse SQL library? Well, this should be working already. The Synapse SQL library is primarily for backward compatibility from Synapse days. You can go directly with the Delta table to Spark read format Delta load and then to the ABFSS link to your warehouse. You need read all permissions on the warehouse files. Workspace admin member contributor have this by default. Well, next question. Are there plans to unify Warehouse, Lakehouse, and Event House? It's confusing. Answer is, currently we do not plan to unify them because they serve different purposes and skill sets. What they do have in common, all your data lake, open format, unified governance, and so on. This is built into all. Why they are separate? Because when you're T-SQL expert Warehouse, zero friction. When you Python Scalar expert, go to Lakehouse. When you high velocity streaming data, real-time streaming, then go to Event House. Bronze, silver, gold. Should I use stored procedures or Spark notebooks? Microsoft documentation states that one of the common architectural patterns is Bronze Lakehouse, Silver Lakehouse, Gold Warehouse. What would be generally more efficient, using T-SQL stored procedures in a warehouse or PySpark notebooks with a Lakehouse for gold layer dimensional transformations? Both is fine is the answer. The efficiency depends on the workload and team. T-SQL stored procs in warehouse, great for set-based transformation, multi-table transactions, familiar for SQL developers. PySpark in Lakehouse, complex transformations, machine learning, more flexible to unstructured data. Additional community questions. My first query is always slow, then subsequent queries are fast. Why? Because, well, this is cold cache versus warm cache. I think you thought already about that. So the first query, data fetches from OneLake storage, statistics may be needed to generate it, compute needs might be to spin up. Subsequent queries, data is in memory, statistic exists, nodes are ready. You can verify that with query insights.exec requests history. Non-zero is a cold start, 0 is a perfect cache hit. Why is varchar max bad for performance? My queries are slow and I noticed all my strings columns are varchar max. Does this matter? Yes, it matters significantly. The problem is statistics and query costs estimations are based on column lengths. Varchar max or varchar 8000 gives the optimizer no useful information. Solution, use appropriate lengths like varchar 100 or something like that. Can I write back from warehouse to warehouse from Power BI? I want the user to update data in Power BI. Is that possible? Unlike SQL Endpoint, which is read-only, Warehouse supports full T-SQL DML. So yes, you can write back either with warehouse.procedures from Power Automate, with paginated report write back, with Power Apps, or with a custom app. Some community tips and tricks and best practices. Avoid tickle inserts. Don't do thousands of single row instance. Batch them because each small insert creates a new Parquet file. You will end up with a fragmentation and slow queries. Use copy into for bulk loads. It's 3 to 5 times faster. And check the code cache, of course, before you complain, and monitor with query insights. Thanks for attending this time about Warehouse. Hope to see you next time. If you want to get notified once I release a new video, please hit subscribe on my YouTube channel. Thank you.